Good morning, students. We were talking about redox reaction, and in redox reaction, we have completed the three concepts to define reduction and oxidation. Concept number first was traditional concept or classical concept. Classical concept number second was oxidation number concept or valency concept, and concept number third was electronic concept or modern concept. In today's lecture, we will talk about types of redox reaction. Remember, redox reactions are of four types. Number first is combinational reaction. Number second is decomposition reaction. Number three is displacement reaction. And number four, the most important type, is disproportional reaction. Now, type first, combination reaction. You know it very well that what happens in combination reaction. Two reactants react to form a single product. A plus B gives you AB is called combination reaction. Now, example, H2 reacts with O2 to form H2O. Dihydrogen gas reacts with dioxygen gas to form water. It is a type of combination reaction, and in combination it is a type of redox reaction. Why it is a redox reaction? You know it very well that what happens in redox reaction. Reduction and oxidation reaction takes place simultaneously. So here, H2, it is the free state for hydrogen, or it is the elemental state for hydrogen. In nature, hydrogen exists in the form of H2. That's why this is called free state. And whenever we talk about the free state, then in free state, oxidation number for the atom is 0. So here in H2, hydrogen exhibits oxidation state of 0. Similarly, O2 is the free state for oxygen, so oxidation state for oxygen is 0 here. Now when it forms H2O, then one electron from hydrogen gets transferred towards the oxygen. Between hydrogen and oxygen is a polar covalent bond. So there are two hydrogen atoms. Oxygen is attracting two electrons from two hydrogen atoms. That's why oxygen develops -2 oxidation state. And from each hydrogen atom, one electron gets transferred towards the oxygen. That's why hydrogen develops +1 oxidation state. Now, H2, when forms H2O, the oxidation state of hydrogen gets converted from 0 to +1. And according to oxidation number concept, increase in oxidation number is called oxidation. So H2 when gets converted to H2O, it is called oxidation of hydrogen. Now, when O2 gets converted to H2O, the oxidation state of oxygen decreases from 0 to -2. And according to oxidation number concept, decrease in oxidation number is called reduction. So when O2 gets converted to H2O, this is called reduction of oxygen. So hydrogen is exhibiting oxidation, while oxygen is exhibiting reduction here. So it's a type of redox reaction. And in redox, it's a type of combination reaction because two reactants react to form a single product. Then comes combination between sodium and chlorine. Sodium combines with chlorine to form NaCl, which is called common salt or sodium chloride, or it is also called table salt. It's the free state for sodium and it's the free state for chlorine. So for sodium, oxidation state will be 0 and for chlorine, oxidation state will be 0 here. Now when formation of sodium chloride takes place, you know it very well. Between Na and Cl, we are having ionic bond. Electrostatic force of attraction is there. One electron from sodium get transferred towards the chlorine atom. So here we can say sodium will exhibit +1 oxidation state because one electron from the valence shell of sodium get transferred to the valence shell of chlorine. So sodium is losing electron, that's why Na exhibiting +1 state, chlorine is gaining electron, so Cl is exhibiting -1 state. Now see the change, from 0 it becomes +1 in NaCl. Sodium from 0 becomes +1 in NaCl, sodium Na +1 because one electron is transferred towards chlorine. Similarly, chlorine from 0 forms -1 state or exhibits -1 state. So when 0 gets converted to +1, 0 to +1, this is increase in oxidation state. So when sodium gets converted to sodium chloride, it takes place by increase in oxidation state. That's why conversion of sodium to sodium chloride is oxidation reaction. Similarly, chlorine when gets converted to NaCl from 0 to -1, it's decrease in oxidation state. So when chlorine gets converted to sodium chloride, it takes place through decrease in oxidation state, and decrease in oxidation state according to oxidation number concept is called reduction. So sodium when forming NaCl, it is oxidation of sodium. Chlorine when forming NaCl, this is called reduction of chlorine. So it is a type of redox reaction. Now, then comes second, opposite, decomposition reaction. You know the definition very well. In decomposition, a single reactant gets converted to 2 or more than 2 products. Then the reaction is called decomposition reaction. So, general representation, AB gets converted to A plus B. So, let us check conversion of H2O to H2 and O2. Compound water gets converted to its elemental form, free state. So when water gets converted to H2 and O2 in presence of electricity or current, then just see the change in oxidation state. In H2O, oxidation state of hydrogen is +1 and for O it is -2. When H2O gets converted to H2, it's the free state for hydrogen. So oxidation state for hydrogen will be 0. So +1 state of hydrogen gets converted to 0. +1 to 0. It's a decrease in oxidation state. So when H2O in presence of current gets converted to H2, this is called reduction of hydrogen. And when H2O gets converted to O2, here it is -2 and here it is 0. The oxidation state of oxygen gets converted from -2 to 0. Increase is there. So conversion of H2O to O2 is called oxidation of water. So this is about decomposition reaction. Then comes displacement reaction. You know what happens in displacement reaction. A more reactive element displaces a less reactive element from its compound. This is called displacement reaction. Displacement reaction may take place between a metal and a non-metal, a metal and a metal, and it can be between two non-metals. So here, reaction between zinc and H2SO4. Zinc being more electropositive than hydrogen. Remember, hydrogen is a non-metal. So zinc will displace hydrogen from H2SO4, as a result of which H2 gas will be evolved and zinc will be converted to zinc sulfate. So here, a metal displaces a non-metal. Metal, non-metal displacement reaction. Now here is the free state for zinc. So oxidation state will be 0 for zinc. In H2SO4, hydrogen exhibits +1 state. Now, when zinc gets converted to zinc sulfate, the oxidation state of zinc changes from 0 to +2. Increase is there. 0 to +2 increase is there. So conversion of zinc to zinc sulfate is called oxidation of zinc. And when H2SO4 gets converted to H2, the oxidation state of hydrogen gets converted from +1 to 0, +1 to 0, +1 to 0. Decrease is there. So this is called reduction of hydrogen. So zinc when forms zinc sulfate, it is called oxidation of zinc, and H2SO4 when forms H2, it is called reduction of hydrogen. So it's a type of redox reaction. Now next one, zinc with FeSO4, metal with metal. We know it very well that the reactivity of zinc is more than iron. So more reactive metal will displace a less reactive metal. So zinc will displace Fe from FeSO4, as a result of which we will get zinc sulfate plus Fe. Zinc state is 0, in FeSO4 state of Fe is +2. In zinc sulfate state of Zn is +2, and in Fe is the free state for iron, oxidation state of Fe is 0. So 0 gets converted to +2, increases there. So when zinc gets converted to zinc sulfate, it is through increase in oxidation state. So conversion of zinc to zinc sulfate is called oxidation of zinc, and when FeSO4 gets converted to Fe, it takes place through decrease in oxidation state. So conversion of FeSO4 to Fe is called reduction of Fe. Then comes number 3, F2 with H2. Fluorine is having highest electronegativity among all the nonmetals. It is the most reactive nonmetal. So when F2 is made to react with H2, fluorine will displace oxygen from here. A more electronegative element will displace a less electronegative element from the compound. As a result, we will obtain HF and HO2. So F2 is the free state for fluorine. Oxidation state of fluorine atom will be 0 here. In H2O, oxidation state of oxygen is -2. Now, when F2 gets converted to HF, oxidation state of fluorine gets converted from 0 to -1. So 0 to -1, it is decrease in oxidation state. So fluorine when gets converted to HF, it takes place through decrease in oxidation state. So conversion of F2 to HF is called reduction of fluorine. And when H2O gets converted to O2, let us see the change in OS, oxidation state. -2 state gets converted to 0. So -2 to 0 is increase in oxidation state. So when H2O gets converted to O2, this is called oxidation of oxygen. Then comes disproportionation reaction, the most important type. Normally in redox reaction, if one substance is undergoing oxidation, then the other substance will exhibit reduction. Oxidation and reduction of different substances there. But in disproportionation reaction, the same compound undergoes reduction as well as oxidation. Remember, it's not the same molecule, it's the same compound. You know it very well that in compound we are having molecules. So some of the molecules will show oxidation while rest of the molecules will show reduction. So in disproportionation reaction, the same compound undergoes oxidation and reduction. This is called disproportionation reaction, or this is called self-oxidation and reduction reaction. Example, HCHO, which is called formaldehyde or methanol. When heated in presence of concentrated NaOH, some of the molecules gets converted to CH3OH, that is called alcohol, and some of the molecules gets converted to sodium salt of carboxylic acid. Remember, as we are having one carbon atom in the reactant, so in the product side also we will be having one carbon atom. We will get alcohol which contains one carbon atom, that is CH3OH, and we will get salt of carboxylic acid which contains one carbon atom, that is HCONA, which is called sodium formate, or it is called sodium methanoate. So conversion of aldehyde to alcohol is reduction, while conversion of aldehyde to carboxylic acid is called oxidation. So the same substance undergoes reduction as well as oxidation. So it is an example of this proportional reaction or self-oxidation and reduction reaction. Then comes next example, benzaldehyde. When heated in presence of concentrated NaOH, gets converted to benzyl alcohol and sodium benzoate. Conversion of benzaldehyde to benzyl alcohol is reduction, while conversion of benzaldehyde to sodium benzoate is oxidation. The same substance undergoes oxidation as well as reduction. So it is also an example of disproportionation reaction. That's all from my side in types of redox reaction. Thank you.